Hafizi bin Zealand as project manager for Novacor from section 018. I'm going to do presentation about Redbus website. So before that, let me introduce our team members. So first member is myself, Hafizi bin Zealand, CB25101 as a project manager. And the second one is we have Fatino Alia Karisha binti Mamano, and the ID is CB25061 as a system analyst. And the third one is Auni Adeline bin Afghani, CB25097 as a programmer. Question number 1 is case study. Online bus ticketing system is a web-based application designed to allow users to search, compare and book bus ticket conveniently through the internet. Provide access to a wide range of bus operator, routers and service types such as seater, semi-sleeper and sleeper bus. Support a more efficient and transparent ticketing process for both user and bus operator. Play a major role in transforming the traditionally fragmented and manual bus ticketing sector into a more organized digital ecosystem. Improve operational efficiency by reducing manual error and improving data accuracy. User acceptance and certification are a critical success factor for the Redbus system. Studies on technology acceptance indicate that factors such as system reliability, performance, expectancy and facilitating condition play an important role in encouraging user. Question number 2 is about our main user interface for Redbus website. As you can see, we provide a figure for Redbus interface.
As you can see in the slide, there are 3 objectives of the Redbus system. First, provide an easy and fast way to book the tickets. The main goals of Redbus is to provide easy and fast way to book the tickets for a bus. It also provides ferry tickets and book activities for their travel destination. By using this website, user can search for available tickets and bus, compare the ticket price, check the available seat and book tickets easily from anywhere at any time. And they can also cancel the ticket anytime they want. Second, other than that, the Redbus website also focuses on digitalizing the previous system of bus ticketing for easy access to the user. By offering a fast and user-friendly website, customers, especially students, can book their tickets from anywhere at any time just using the internet. It also reduces the time waste and the long queue in the manual system, seeing the website provide a 24-hour service. Furthermore, the Redbus system allows the admin to manage the records of the bus and the scheduling of bus. Admin can add, update or delete bus details, manage routes, set schedule and monitor on how many available seats there are. This will help the system do things more effectively and in a more organized way.
For services, main functionalities. Booking bus tickets. Allow user to book bus ticket for different routes and destination by comparing price, bus type and send availability in one place. Redbus connect traveler with a wide network of bus operator, giving them multiple options to choose from based on comfort and budget. Engage with user through review and social media, helping customer make informed decision and improving overall customer experience. Online ferry ticket booking, making water travel easier and more accessible for passenger. User can search and book ferry ticket for various routes, especially in coastal and island region. Help traveler plan their journey in advance without the need to stand in long queue at ferry terminal. Allow user to view ferry schedule, seat availability and ticket price in one place. Next, Redbus has introduced their new features called Thing to Do. Helps travelers discover and book activities and experience at their travel destination. By providing detailed information such as description, price and availability, the feature helps users choose activity that match their interest and budget. Travelers can conveniently book both their travel and activities through Redbus. Not only save time but also help user plan well-organized itineraries. Online payment system. Support multiple payment options including credit or debit cards, e-wallet and bank transfer with secure processing, ensuring a smooth and flexible transaction process for user. All transactions are processed through secure payment gateway with encryption to protect user financial information and sensitive data is not stored on the platform. Confirm the booking and issue an electronic ticket. Language and currency selection. Allow users to select their preferred language on its platform, making it easier for people to navigate and understand booking details. Helpful for users who are more comfortable using regional or local language. Redbus support currency selection mainly for international users. Helps users clearly understand ticket costs and avoid confusion during payment.
First, dependability and security are paramount for any e-commerce platform that handles sensitive user data and transactions like Redbus. In order to ensure the system is reliable and protected, it requires engineering to focus on implementation, concurrency control mechanisms within the booking service to ensure the process of checking, holding and confirming a seat is an atomic transaction that prevents multiple simultaneously users from successful booking the same seat. When a customer selects a seat, the proceeds to payment, and that seat is reliably reserved across the network and for all other users browsing the Redbus website. Next, designing complex transactional logic is crucial to ensure that customer financial data is securely processed. Software engineers implement secure payment gateway integrations supporting methods like Visa, Debit, and Touch and Go e-wallet, protecting customer financial information. Second, the fundamental goal of efficiency and scalability in software engineering is to ensure the platform's performance, speed, and capacity and can handle increasing user load without degrading service. The primary engineering focus for achieving this is to design a modular, microservices-based architecture and implement load balancing to distribute traffic, which guarantees that no single component fails under high user demand. Usability and experience is a critical attribute in software engineering that focuses on the ease with which users can interact with the software, learn its function quickly, and operate it efficiently to achieve their goals. The core engineering focus here requires translating abstract UI or UX designs and user flow requirements into a functional logic and initiative interface with clear call to action elements. Software engineers ensure that navigation is simple and interactions are smooth so users can complete booking tickets with minimal effort. In Redbus, this is demonstrated through the implementation of a highly interactive seat selection map and the use of tickets in the form of SMS or QR codes and as paperless boarding passes. Maintainability and evolution attribute is fundamental to future-proofing the platform as it ensures the entire system is built with an adaptable structure that allows it to be easily modified, updated, and extended in a robust manner to respond effectively to constantly changing market demands or new regulatory requirements. The critical engineering focus for achieving this center on designing the software using strong modular programming principles such as microservices or a clear separation of concerns, which ensures that different components can be independently modified, thoroughly tested, and deployed without inadvertently affecting the integrity of the entire system. Software engineers specifically structured the code to cleanly separate new functionalities such as the ferry ticket booking functionality from the core bus booking logic. This architectural choice is vital because it ensures that any changes or updates made to one service, for instance adding a new ferry operator or modifying bus seat layouts, do not introduce bugs, cause downtime, or create cascading failures within the primary bus booking selection.
For question number 4, give 2 reasons why the software process model was chosen. Describe and explain clearly process activity based on the selected software process model. So for the Redbus website, I choose incremental. First, my reason is ability to handle changing and evolving requirement. Second is early delivery of core system functionality. Process activity based on the implemented software process model, we have requirement analysis, testing and integration, design and implementation, deployment and feedback.
In requirement engineering, first we have requirement elicitation. Example, the technical staff of the developer team noticed through analytics that many users of the Redbus system drop out at the payment stage. They also run customer interviews and surveys where users specifically request faster checkout methods. This feedback confirms a clear need for simpler payment options such as Touch and Go e-wallet, GrabPay, or Shopee Pay. And then we have requirement analysis. For example, after requirement elicitation, Redbus stakeholders and the end user discuss to set clear goals, sort out issues, and record every requirement. The gathered requirements will be examined by the analysis team of the Redbus system to resolve conflicts and document all the key requirements. This includes determination of Redbus system needs and ensuring Redbus system compatibility with APIs. Next, we have requirement validation. Validity: does the Redbus system need support? Does the Redbus system support the customer's needs? Consistency: does this feature contradict another requirement? Completeness: is everything the system makes sufficiently specified? Realism: is the implementation of these requirements achievable given the available budget and technological constraints? Verifiability: can the requirements be checked? And then we have requirement management. As the Redbus evolves, the requirements of its service frequently change. Second, we have design. There are 4 design aspects, which are architectural design. This is where the overall structure of Redbus system is determined. It also identifies the main module of the system. And then we have interface design. In the Redbus system involves developers creating the user interface design, what the user sees and interacts with, and defining how the system's components communicate with each other. This is achieved by specifying the inputs, outputs, and data exchanged between modules. And we have component design, where Redbus developers take each major system component and design how it will operate, including its specific functions, inputs, and outputs. This ensures that complex tasks are broken down into manageable, independent, and reusable modules. And then we have database design, where Redbus developers design the Redbus system data structure and how are these going to be represented in a database. Third, we have implementation. At this stage, the Redbus system designs, including the architecture, components, and interface, are translated into functional software. The development team writes code to implement features that were designed in the design phase. And we have 4, testing. First, development or component testing. This phase focuses on verifying that the individual or components of the code function exactly done in isolation by the developers. Then we have system testing. System testing verifies that the fully integrated system has all components working together, meets the non-functional requirements, and that all modules interact correctly. And we have acceptance testing. This final phase involves the actual end users or product owners validating that the system meets the original business requirements and is suitable for use. The last one, we have deployment. Once an increment is tested and validated, it will then be deployed into the main system. After the bus ticket module is completed, it will be released into the Redbus client environment. The next increment, such as ferry booking module, will start from the requirement engineering engineering phase and repeat until Redbus system is completed.
The incremental model applied to Redbus development for expected deliverable for each activity. First, we have requirement elicitation, which is Redbus domain, service of Redbus system, and requirements from Redbus stakeholder. Second, we have requirements analysis. Redbus use case diagram, expectation from the end user, and requirement documentation. And the third one, we have requirements validation, which is requirements validation checklist, Redbus prototype, and Redbus UI mockup. And fourth, we have requirements management, which is revised Redbus requirement change log, and updated version of Redbus requirement document. And next, we have design. First, we have architectural design, which is system architecture diagram and Redbus component. Second, we have interface design, which is Redbus UI and Redbus UI mockup. And third, we have component design, which is class diagram. And the last one is database design, which is Redbus database scheme. Next, we have implementation, which is Redbus source code files for front end and back end, and Redbus API integration. Next, testing, which is test report, and the last one, deployment, which is deployment report.
As you can see, the diagram show the Gantt chart for Redbus website. So for question number 5, I will discuss possible handover problem and explain how it will affect my project entirely. So I, as a project manager, and my handover problem is confidentiality violation can occur when this information is accessed, shared, or exposed without permission and authorization. Ensure that my team know what confidentiality and follow Redbus strict rule, and it's also my job to prevent any of these bad practices. To upload and prevent confidentiality breaches, Redbus must implement strict security control and clear policies throughout the project lifecycle. It is also important to enforce regular audit, monitor data access, and ensure compliance with legal and organizational security standards.
Based on my role, a possible handover problem is incomplete or unclear of user requirement. It is important to note that all the requirements are stated by the customer so that the system will be as the customer expected. But me as a system analyst make mistake during the progress of gathering information. The system might have lacked part in the system as the customer want. When a system analyst meets with the customer and the customer is confused and does not have any knowledge about the software, it can lead to miscommunication. It is also important that customer clearly state what they want so that all the detailed information can be included in the system. Sometimes, the user requirements are discussed verbally but not properly right in the documentation. As a result, developer may misunderstand what the user really wants. In the Redbus system, this problem can happen if requirements for ticket booking or seat availability are not clearly explained. For example, if I as a system analyst do not clearly state how the seat availability should update in real time, then developer may build a system that allows the user to book the same seat and tickets. Developer may implement the wrong feature or function, and tester may not know the correct expected output, and also the team needs to redo the work again. Furthermore, this will cause delay and a lot of time is needed to finish it. Hence, not only there was not complete as the customer want, it needs a lot of time longer than the agreement, which leads to the failure to fulfill the requirement given by the user.
Based on my role, one of the possible handover problems is overemphasis on code over documentation. During code writing, me as a programmer might be more inclined to focus on producing functional code and less committed to dedicating adequate time to documentation activities. Since I put most of my effort into typing the actual code, I tend to create incomplete and weak documentation. Therefore, this prevents a comprehensive understanding of the system's design and implementation. For the Redbus system, imagine that a complex feature is built, such as the dynamic fare adjustment module, which automatically changes ticket price based on demand and time of day. To meet a tight deadline for an increment, programmer rushed the coding phase, creating complex logic for how the ticket pricing rules work, but failing to write a clear document explaining the rules, parameters, and exceptions within that logic. When this module is handed over to the QA, quality assurance team, or the maintenance team, they receive working code but consist of no instruction manual. Thus, they cannot fully grasp the complex calculations for the surge pricing or even last-minute discounts, and perhaps requires the maintenance team to manually reverse engineer the code. This trial and error process is slow and expensive and greatly increases the risk of introducing new bugs into high-value and high-risk components. Other example of affected part in the Redbus system is the search service and the bus operator API interface that communicates with thousands of external bus companies. Me as a programmer may change an internal function in the search service, such as how dates are formatted, without updating the external API documentation. Then the maintenance team maintaining the bus operator API receives incorrect data from the search service, causing the entire system to fail silently.
As you can see on the right, there are the diagrams that show the layered architecture of Redbus system. There are some reasons why we choose the system architecture pattern. The first reason is that layered architecture have better separation of responsibilities compared to other system architecture pattern. Layered architecture separates the Redbus system into many layers, where each of the layers have their own specific function and responsibility. This improves the system organization and maintenance much better. For example, if the Redbus website interface is redesigned or updated, such as adding new features, only the user interface layer is modified, while the other layers remain unchanged. The second reason is that the system architecture pattern improves the scalability and security of the Redbus system. This architecture pattern allows the system to handle a big number of users at the same time, so each layer can be scaled and upgraded independently based on the user's demand. For example, many users may search and book bus tickets at the same time, especially during school holiday or semester breaks.
Section 7. I will describe two benefits of involving user in release testing at an early stage in the testing process of my case study. Then I will describe one disadvantage to user involvement during the project validation and verification stage. I, as a project manager, and my first benefit, I will choose early identification of user-centric issue. Allow the project team to identify usability and functional issue that may not be apparent during internal testing. Real user can provide feedback on critical workflow. Help ensure that the system aligns with actual customer expectation and usage patterns. Second, improve requirement validation and stakeholder satisfaction. Help validate that business and user requirements have been correctly interpreted and implemented. User participating in release testing can confirm whether features meet their needs. Ensure that the delivered system provides real business value. For the disadvantage, increase project complexity and schedule risk. User may request additional feature or change that fall outside the original project scope, may demand interface changes or new payment option late in the development process. Accommodating this request can delay timeline, increase costs, and complicate release planning if not carefully controlled.
The two benefits of involving user in release testing at an early stage in testing process of the Redbus system are early validation of user requirements and improved usability and user experience. As a system analyst, involving user early in the release of testing helps to confirm that the system needs what the user wants and meets the actual user requirement. User can check whether the system function and feature match what they need and expect. For example, user may test the Redbus ticket booking system and inform us whether the system and feature meets their needs and expectation or not. This will allow corrections to be made early before releasing the final system. Next, another important benefit of involving user early in release testing is that it helps improve system usability and overall user experience of the system. Even if the system works correctly from a developer point of view, it may still be difficult for user to understand and use the system. Developer and tester usually test the system based on the technical requirement, but the user tests the system based on real user and daily experience. In the Redbus system, user can test important functions such as confirmation of booking ticket, seat selection availability, making payment method, and searching for bus. For example, through early testing, user may say that the instructions are not too clear and have too many steps in the booking process, which make the user confused using the system. This feedback is important to allow the system analyst to suggest change to the user interface and redesign the website screen layout. One advantages of involving user during the project validation and verification stage is that it can cause project delays due to frequent change requests from the user. When user requests new feature or change to requests last minute that were not included in the original requirements, it will delay the time and deadline of the development process. Even though this request may improve the system, it can cause problems with project timelines and budget. For example, user may request change for adding new payment methods in the system, such as adding GrabPay or ShopeePay during validation testing. As a system analyst, handling this new request at the last minute is difficult because the system design and code are already finalized. Furthermore, different users may give different opinions, which can lead to conflicts in decision making. This will make the system analyst hard to decide which feedback should be accepted.
The first benefit of involving users in release testing at an early stage in the testing process of the Redbus system is enhanced user satisfaction and trust. Engaging users in early release testing allows the programmer to receive early feedback and identify usability issues and improve system functionality. In a Redbus case study, early users can help identify issues such as logic errors in discount code stacking. For example, they might attempt to apply a 10% promotional code simultaneously with an existing loyalty voucher, then an error revealed where the system either incorrectly stacks the discounts or rejects a valid combination. This feedback enables programmer to fix and improve the system immediately. Consequently, this strengthens user loyalty and retention, ensuring users motivated to keep using the system and recommend it to others. Second, it helps building confidence. Involving users early helps make sure the system will pass the final user acceptance testing (UAT). Programmer lets users try the system during the alpha testing stage to search for buses, pick seats, and pay for tickets. When these users give comments, the programmer can see real problems they might have missed, such as unclear price breakdowns where taxes and fees are difficult to understand. This input also highlights payment troubles such as a confirmation page that is too slow or confusing to use. By fixing these issues gradually based on real reviews, the programmer corrects mistakes before the final deadline. This approach creates a much lower risk. Next, disadvantage to user involvement during the project validation and verification stage. it is high volume of subjective feedback. From my perspective as a programmer, involving users can generate a lot of personal opinions that are hard to compare against the actual technical requirements. For example, while testing the bus photos or operator reviews on the search results page, users might complain about the minor details such as the color of the star ratings or the size of the text. To a programmer, these are usually just personal style preferences rather than real system errors. However, I still have to spend a lot of time sorting through these subjective comments to find genuine technical bugs, such as photos not loading correctly on certain mobile browsers. This distracts the team from taking more important backend processes like payment security, which are essential for the system to work properly.